Hi, I'm at TU-Automotive Europe 2016, and today I'm joined by Angus Lyons, consultant with Manor Racing. Hi Angus, thanks for joining me.
Pleasure.
Now obviously racing, and your particular type of racing, is experimental, and as such it's testing new technologies. What sort of technologies that you're using now do you think can get into the ordinary car we'll see consumers using?
I think more than in a long time, as far as Formula One goes. Both the powertrains are now far more relevant. We've got hybrid technologies on the car, we've got energy storage, electrical energy storage systems, energy recovery. We have active aerodynamics on the car, and the wireless and connectivity of the car. We're gathering more and more data off the car and using that essentially like a bit of fleet management, just in a much smaller and compressed period of time. To understand how the car is being used, how the car is performing, what the driver's doing, is he doing the right thing, and to allow us to get the best out of the car within the specific life that we want out of it.
So how, if this was applied into a road-going vehicle, how would you envisage it helping the driver? Would it be an over-the-air type situation where he'd get recommendations, or?
Certainly that kind of technology is very relevant. We are constantly monitoring how the car is being driven. We are trying to get the car to be as fast as possible. But that is by making it efficient. So we're trying to make sure the car is being used efficiently, the driver is driving efficiently, we're using the energy recovery and deployment systems efficiently. And in some ways that's very relevant to road car, that we're trying to reduce carbon emissions and carbon footprint of transportation worldwide. So monitoring real time what the car is doing, whether it's a car, truck or a bus, and using that to help and understand and feed back to the driver, as well as just not necessarily feeding back to the driver, but train the automated systems to understand what's coming up, what they've done in the past, what their current status in terms of energy or temperatures. And as I say, it also goes beyond there to prediction of end of life. In F1 we do a lot of prediction. We don't want to carry around anything that we don't have to. We also have a limited amount of fuel and energy that we can carry around during a race. So we're trying to make sure we use that most optimally over the race period. In road cars, you're wanting to make sure that you get the maximum life out of your brakes, that you're not having to bring the car in for service unnecessarily, but likewise that your brakes don't fail early. So I think a lot of the mechanical systems, reliability monitoring is relevant, and obviously a summary of that needs fairly low bandwidth to send wirelessly, as well as all the efficiency, and that can lead to driver training as well as self-learning algorithms within the powertrain and energy systems control.
And naturally it would percolate into making cars more efficient long term. Absolutely,
yes. Yeah. I mean, if you look at an F1 car at the moment, since the introduction of the hybrid powertrains, we're using 50% less fuel. So in 2013 we were using 150 kilograms of fuel in a race, now we're using 100 kilograms. The cars haven't got any significantly slower. That's by efficiency. So, and I think the regulation changes we saw just a couple of years ago have pushed that side of Formula One to be far more relevant. So we've got companies looking at the technologies on the car, nothing to do with the real-time monitoring, just the motors, the energy storage, the combustion efficiency even of the internal combustion engine. But a lot of that, from our point of view, in terms of getting the best out of it as a race car, is the real-time monitoring, the real-time analysis. There's so much data comes off the car that we can't analyse it in its entirety, so we rely heavily on our own tools and algorithms that we develop, real-time data analysis systems, to give us snapshots and summary of information, and that's really very much the same kind of thing that's being proven to work across the industry to improve reliability, improve safety, and reduce emissions.
Excellent. Well, thank you very much for talking to me. Thank you. Thank you.